Hello and welcome to class. In this video, we'll be studying about equation of straight lines or equation of straight lines. Let me complete that. So we're studying equation of straight lines. Now, we are still dealing with coordinate geometry of straight lines and want to look at what the equation of any given straight line looks like. We've had to study quadratic equations, and where we were able to deduce that whenever a quadratic equation is plotted, the graph of it is plotted, what we have is always in this form, a parabola. All right, whenever you plot, sometimes it could be like this, it could be like this, but we were able to find out that whenever we plot the graph of a quadratic equation, we always have a parabola. Now for straight lines, all right, when you have a Cartesian plane, your x-axis and your y-axis, your x and your y-axis, whenever you plot any equation there and you have a straight line in that plane, it could be like this, it could be like this. So far that is a straight line, that equation always has the general form. So want to study the equation of a straight line. Now you should know that the general equation, the general form of the equation of a straight line is given by this: y is equal to mx plus c. This here you must not forget. Y is equal to mx plus c, where m is equal to the slope or the gradient, which we have looked at how to calculate the slope or the gradient. That is the gradient of the straight line. That is how steep it is, how it is turning when you are moving towards your x. How does it respond towards the y-axis? We are going to look at that as well. Now the next one is c. The c is the y-intercept. Remember that the intercept is the point where the line cuts your x and y-axis. So but for straight lines, the c there is just the y-intercept. That is the point where the line cuts your y-axis. We don't need the x-intercept as part of equation of a straight line. We only need the y-intercept. So the general form of your straight line equation is given by this: y is equal to mx plus c. As I already noted, m is the slope or the gradient, while the c is the y-intercept. All right, your x and y remains the variables. Your m and c, they are constants. Your m and your c are constants. Constant by constant will mean that they are digits. They are not variables. They are digits. So they have, it can be -1, it can be -2. They can even be fractions, but they are constants. They are not variables. The only variables that you have there are your x and your y. All right. Now let's look at a graph. Let's go to a graph and practicalize what we're saying. Now I have a mini graph here. So let's say we want to plot the graph of this equation. Let's say this is the equation: y is equal to 2x minus 1. Remember that we have to choose the values. We have to choose our values for x first of all. Then after having chosen the values, we'll then use the equation, given the equation, to generate our y. So let's use our x points to be minus 1, 0, 1, 2, 3. Okay, let's stop it there. Minus 1, 0, 1, 2, and 3. Then for us to get the y, we would have to use this equation here to generate the y. So how do we do? For when x is -1, we'll replace this x here with -1. So that is 2 times -1 will give us -2. Then -2 minus 1 will give us -3. All right. When x is 0, we also replace the x with 0. 2 times 0 is 0. 0 minus 1 will give us a -1. When x is 1, we replace the x with 1. 2 times 1 is 2. 2 minus 1 will give us 1. When the x is 2, we replace the x with 2. 2 times 2 is 4. 4 minus 1 would give us, have I made a mistake? I'm not sure. So 4 minus 1 will give us 3. And when x is 3 will replace here. 2 times 3 is 6. 6 minus 1 will give us 5. So we have these as the values. The next thing we'll do is to go ahead and plot the values. So we have this first one here. When x is minus 1, that is at this point here, that's where x is minus 1. Y is minus 3 at this point. So we are going to plot where they intersect. That is somewhere here. The next one, when x is 0 at this point. When x is 0, y is minus 1 and y is minus 1 here. So that's where they intersect. When x is 1 at this point. Y is 1 as well. Y is 1 at this point. So when they intersect, we plot that point. Now when x is 2, that is at this point now. Y is 3, that is somewhere here. So we'll plot that point. And when x is 3, that is here. Y is 5. Okay, we can't be able to get that to be somewhere up above here. Okay, now let's try to join this line. Let's try to join them. Looking for that already. Okay, now when we join these lines, let's draw a line, straight line to join these points. When you use a ruler to draw it, you would get a straight line. You would get a straight line. Now let us look at something. Let's try to let us analyze this equation that we have here. That is the equation. We plotted this equation, the graph of it, and we arrived at a straight line. We're having a straight line here. Now let us look at this equation. Notice something. Now let's go to the values of x that we've chosen. When you check the progression of the x values, that is from minus 1 to 0 to 1 to 2 and to 3, you find out that you are adding 1 at each time. So when you add plus 1 to this one here, you get a 0. When you add plus 1 to 0, you get a 1. You add plus 1 to 1, you get 2. Add plus 1 to 2, you get 3. Right? So we see that on the x axis, we are adding plus 1 on our x axis. That is for x axis. Now consider the y. Look at what is going on in the y. Look at what's going on in the y. Now for your y, we have the first one to minus 3. The next one is minus 1. This one is 1. And so minus 3 minus minus 1 will give us a 2. So we have a 2 here. Minus 1 also. Difference between minus 1 and 1 is also a 2. Difference between 1 and 3 is also a 2. Difference between 3 and 5 is also a 2. So what do we say about this? So we now see that when we make one move, plus one move towards an x-axis, the y is moving 2 times. When we move once towards our x-axis, y is moving 2 times. Come back to the graph. Let's look at this graph. Look at the graph. Now, this is our x-axis here. We are at 1 at this point. We are at where x is minus 1, right? That is here. Now, when we move 1 point, minus 1 plus 1, that will give us a 0 at this point. Now, when x is minus 1, y is still minus 3 here. Now, can you observe what happened? If you should now move 1 point, your x minus 1 plus 1 will give us a 0. Will be at this point here. Will be here where we have a 0. Now look at your x, your y. Your y has jumped from minus 3. It is now at minus 1. That is 2 moves. I'll say that again. Look at the progression, the movement. We want to move in steps of 1 on our x-axis. That is, we'll move from minus 1 to 0, from 0 to 1, from 1 to 2. Now, when I'm making that move, observe what the y is doing. Remember that we said that we had a deduction here that when x is making moves in steps of 1, y is moving in 2. Y is moving in steps of 2s. So look at our x. Initially, the value of x is at this point where x is minus 1. Now when the x moves 1, that is from -1 to 0, x becomes 0 now here, y jumps from -3 up to this level, that is -1, 2 steps in between them. Now if the x should move again, 0 plus 1 will give us a 1. When the x moves 1 here, look at what has happened. The y has jumped again from -1 to 1, that is steps in 2. When the x will move again, step of 1, that is 1 plus 1 will give us a 2. The y again will jump to 3, 2 steps to 3. When the x is 3, that is another step of 1 in the x direction. Y also jumps 2 times up to get to 5 and all that. So that is now that jumping of y when the x is moving in one in steps of 1 is what we refer to as the slope. That is what we refer to as the slope. That is what we refer to as the slope. So let us go ahead and also reanalyze what we have here, the equation. Now we remember that the general equation of general formula for general form of a quadratic linear equation is always mx plus c. Now consider this equation here. We have determined that the movement of y when x is moving in steps of 1 is 2. So you can see that this equation has a slope of 2x. Now how do we get the c? Remember that we said that the c is the point where the equation, the line cuts the y-axis. Now where did the line cut the x-axis? Where does that happen? Where did that happen? That is at this point here, the y-axis. That is the point where value of y is -1. So in this case our c becomes -1. So when we have plus c, which is -1, so plus -1 will give us a -1, and we arrive at this equation which we originally had. So it means that we can deduce, we can use a given straight line, a sketch, or a standard or a scaled one. We can use it to deduce the general form or the equation of that straight line. What you have to watch out for is when x is making moves, how does y react? When x is moving in 1, steps of 1, how many steps, how many jumps does your y make? So the jumps that the y makes is what we refer to as a slope, while the point where the straight line cuts the y-axis is where we have the intercept. All right, so this is really what we refer to as the equation of a straight line. So the general form of a straight line is always in the form of y is equal to mx plus c, where I've already noted that the slope is the m and the intercept is the c. Don't forget, it is not the x-intercept, it is only the y-intercept. That is the point where the line cuts the y-axis. Okay, now something happens then. Let's answer this. Sometimes you can be given equation. Now let's see how to derive the slope, that is the intercept, and the gradient from the equation of a straight line. Let's consider these following examples. That is how what we're looking at now is how to derive the slope and the intercept from the equation of a straight line. That is what we're looking at this point. So let's consider following some equations. Let's look at this first equation here. Y is equal to 2x minus 3. Let's look at the second one. This is the second one. We're going to look at 3 of them. Let's look at this second one. 2y is equal to 5x plus okay, let's say plus 2. And the third one we'll consider is this 6x plus 2y minus 5 is equal to 0. Now what are we trying to do? We want to derive we want to find out the values of the gradient, that is slope, and the intercept from this given equation. Now for the first, number one, let's consider the first one. In the first one, remember that our equation, general equation of a straight line, is always in this form: y is equal to mx plus c. So what we have to do in the first one, we have, this is the equation, 2x minus 3. By comparison, when we compare these two equations, we can see that m is equal to 2, right, while c is equal to minus 3. By comparison, when you compare the first equation, the first equation is a simple case whereby no work is required, because you have the equation arranged in the form of the equation of a straight line, mx plus c. So you just compare them. The m is like m is standing in for where 2 is, then your m, that slope, becomes 2. Then the c is standing in for where the minus 3 is, your c becomes minus 3. And that is the answer to this particular number 1. All right, that's number 1. It's clear and simple. But number 2, look at number 2. For the second one, we have 2y is equal to 5x plus 2. But we have the general form of a straight line, the equation of straight line, to be in this form. Okay, let me even write it under it. Let me write it under. So we have the equation of a straight line to be equal to y is equal to mx plus c. Now when you compare them, they are not the same. How do I mean? In the general formula, the y has a constant of 1, but looking over here, the y is having 2 as a coefficient, not constant, not coefficient. The y here is having 2 as a coefficient, even though that on this side they might look okay, but when you look at this side, the y's are not the same. So the first thing that you want to do is to make the given equation to be in the form of your general form. So how can you achieve that? How can you make this y here to have 1 as a coefficient? You have to divide 2, but you know in mathematics, what you do to one side, you have to do to other side. So for us to achieve that, we have to divide through. We have to divide this whole equation, divide it through by 2. So we're having, so what we have to do is to divide everything. So we now have 2y divided by 2 is equal to 5x over 2 plus 2 over 2, and this, simplifying it, to give you 2 cancels 2 here. You have y is equal to, you have 5 over 2x plus 2 over 2 will give you 1. Now you have a resemblance. Now bringing down back your equation of a straight line, y is equal to mx plus c. By comparison, you see that they are similar. The y's, they both have 1 as a coefficient. You have x here, you have the c's here. So by comparison, it is safe to assume that your m in this case is 5 over 2, that's the slope, whereas your c, the intercept, in this case is 1. And you are correct, that is what it is. So by comparison, the first thing that we have to do is to rearrange the given equation to be in the form of the general form of a straight line, general equation of a straight line. You have to rearrange the given one to be like that. Now let's consider the third example, that is 6x plus 2y minus 5. That's number 3 now. 6x plus 2y minus 5 is equal to 0, if I'm correct. Let me check. 6x plus 2y minus 5 is equal to 0. Now we want to find the slope, that's the gradient m, and the intercept c of this equation of a straight line. Wow. When we write our general form of a straight line, that's general equation, y is equal to mx plus c, they have no semblance, no resemblance at all. You have it scattered, but what you have to do first is what? Rearrange. You have to rearrange this particular one to be in this form. You have to rearrange it. Let's see how we can do that. Now we know that we want y to be on the left hand side. Remember that you have the left hand side of the equation and you have the right hand side of the equation. In this, here is the left hand side, then here is the right hand side. Note that. So what we want to do is to make sure that our y is on the right hand side of the equation, while the others are on the left. The y is on the left hand side while the others are on the right hand side. So let's do that. So what we do, we have to retain the 2y this side is equal to, when we subtract these other two from this side and transfer them over to the other side, what we have, this plus 6 here over the other side becomes a minus 6, right? This plus 2, not 2y now, this minus 5 here, when we add minus 5 again, taking it over to the other side, it becomes plus 5. So what we have done is just to like carry over the other values that we don't need over to, but you know that when they are moving over to the other side, their sign changes. So when this plus 6 here moves over from here over to the right hand side of the equation, it becomes minus 6. And when this minus 5 here moves over to this side of the equation, it becomes plus 5. The 2y remains unmoved. It is still at the left hand side of the equation. Now you are getting somewhere. It is beginning to look like this one, y is equal to mx plus c, but we still need to do something. The coefficient of the y here is still 2. So what do we have to do? We have to divide here by 2 and do that on all sides to balance the equation. Now when we do that, 2 divides 2 cancels the 2, you have y is equal to, here 2 cancels minus 6, that will give you minus 3x plus 5 over 2, which can give you 2.5 anyway. Now when you bring your general equation of a straight line, y is equal to mx plus c, and compare it, of course they are now similar, so you can now make the deduction that m, therefore the m is equal to minus 3, as you already guessed, and the c, the intercept, is equal to 5 over 2, or 2.5. So in other words, it means that for the line that has this equation, what it means is that when x is moving in steps of 1, the y is jumping 3 steps up, is moving 3 steps up, and the point where the straight line cuts the y-axis is at the place where, or the point where you have the value of y to be 2.5. That's 5 over 2, 2.5. That's the interpretation of this line. That's how we interpret this line. That the slope of this line, that is, as your x is moving in steps, as x is moving in steps, maybe you choose the values x steps of 1, the point where you have the y rather jumps in threes. When your x is moving in steps 1 1, y jumps 3, and the point where the y cuts the y-axis is at the point 2.5, which is also 5 over 2. So that is how we derive the slope and the intercept of a straight line from the given equation of the line. All right, so we have had to look at the plotting of a straight line. Whenever you plot a linear equation, an equation that has the highest power of the known as 1, whenever you plot a linear equation, you will always get a straight line. When you connect the points, you must always get a straight line, and the general form of that equation is always in the form of y is equal to mx plus c, where m is the slope or the gradient, while the c is the place where you have the y-intercept. That is where the y cuts the line cuts the y-axis. Okay, this is where we're rounding up. So let me give you like an assignment. So find the m, that's the slope, and c, intercept, in the following equations. So the first one y is equal to 3x plus 5. Second one, y minus 2x is equal to 3, and the third one is 3y plus x plus 6 is equal to 0. So watch this video and then try this. Find the slope m and the intercept c from this equation of straight lines, 3 of them given, and then get back to me. So I'll be seeing you in the next video. Bye.